We're good. Okay, this one, right? Can you go up towards the top and hit slideshow for me? It's on slideshow, and then from beginning. And then I'll fast forward it. I can do it. Okay. It's kind of dark. That's okay. We did medical, environmental. We did production, manufacturing, construction.
We were on materials.
We're on materials. Okay. So let's talk about materials. You okay, Destiny?
Yeah, just I'll put my golden things that
Weird. Do you want a new one and you can catch up? Did you find it? Okay. Okay. So materials technology, that's the development of materials with outstanding combinations of mechanical, chemical, and electrical properties that make other advances possible. Things in this category, one of your examples is your mosquito repellent clothing. Clothing that repels mosquitoes. We've got artificial skin grafts for burn victims. Shh. And we have advanced building materials such as composite decking. This is the composite decking. It's made out of plastic, recycled plastic bottles and sawdust. Okay? The thing to remember when you're dealing with materials technology is you're not changing each material. You're just combining them. It's a mixture. So you're not changing it at the chemical level. It's just a mixture. And that mixture brings out the best of all the properties of that. Okay? So did you get your examples?
No.
Okay. You have mosquito repellent clothing. You have artificial skin grafts. And then composite decking.
What was the other ones?
Artificial skin grafts.
Okay.
So when you get burned now, instead of having to take skin from other parts of your body, they can do artificial skin. It doesn't work on all places, but it will work for some.
Number 3.
3 is composite decking. This word right here. Composite decking. Words, thank you. I'm out of breath. That's bad. Out of okay? So let's talk positives and negatives.
We're not done.
Okay, everybody good? So our positives. Do you see this plane down here? They're starting. Our cars have plastic on them. Why do we put plastic on cars? Like make them lighter. Why do we want them lighter? It's what?
Less cheap.
Else? Why?
The car that we used to drive, that all she had to pay was $20 and she would get she would have her car would be on intake, pay $20 and be on full.
Wow. So those lighter cars get you better gas mileage. Okay?
Yeah, but it can't hold as many people.
Some of them can. Okay? This is all you have to write for a positive. That new materials let us use reuse recycled materials, which helps the environment. That's all you have to write. For this is the only positive you have to write. You can fill that whole box with this. So new materials, able to reuse recycled materials to help the environment. On materials technology, positive. The positive on material technology is that new materials, we're able to reuse recycled materials to help the environment. Right? Can I go to the negatives? No, they're having a problem with the image server.
So it looks like we're going to be here more than what we've done.
I think so. Anything else? Okay, negatives. With our new materials, we don't know how long the materials will behave over long periods of time. So when we look at composite decking, don't touch. Composite decking is great because you don't get splinters. You don't have to maintain it the way you would a wood deck, right? You have to paint it. The wood doesn't rot. But we don't know in 100 years what it will look like. We know what wood will look like in 100 years when we look at houses and other things.
We don't know.
But we have no clue what this is going to do in 100 years. It's unpredictable over long periods of time.
All of it or just the wood?
Do what?
Do you write an all or just the
You can write just this for your negative. You don't have to write any more. Okay? Are we good? Okay, that's okay. Are we good?
No.
Okay, we can wait. Yeah. Football. Ooh. Ah. Okay, you ready? Okay. Transportation technology. This one's really cool. Okay? Transportation technology. That's how we move people, animals, produce, materials, and we can move them all over long distances, right? From one place to the next. And we've got lots of different areas. Yes, ma'am.
They invented that little thing from Back to the Future.
The hoverboard. Okay? So we have flight, and flight covers airplane, rockets, space shuttles. We've got land that does train, subway, automobile, and bicycle. We have water, commercial and cruise ships. And we have non-vehicle, like our conveyor belts in our assembly line that move the product, right? And then the pipelines. What do pipelines carry? Oil, water, right? All of those things that we're able to transport from one place to another. How did Christopher Columbus get to the New World? By a boat, right? What kind of ship was it?
Mayflower.
It was made of wood. The Mayflower was the Pilgrims about 200 years later. That's okay. How did the ship get there? Did it have motors? No, what did it have? Sails, right? And so the wind moved the ship. How long did it take Christopher Columbus to get to the New World? How long? Wait, hold on. Shh. How much? I think it was 17 months.
Can I look it up?
66 is the Pilgrims. Okay? So in 200 years, we went from like 17 months to 66 days. The Titanic. How long did it take the Titanic if it had completed its journey?
Not too long.
From England to America?
30? 21?
A month.
8. Yes, sir? 8 days. It took 8 days if it had completed its journey. So we went from 17 months to 66 days to 8 days. And now, how long does it take me if I get on? Okay. If you go on the supersonic jet, it will take about an hour and a half.
Oh, there is a possibility. Okay, so where can you?
So if we're talking about Christopher Columbus, when he to get rid of, how would he have gotten rid of it?
Fire.
Fire. He would have burned it, right? Would it have all burned?
Yeah.
Yes. Two. Part. Okay? You'd have to disable it, right? You'd have to dismantle it. Columbus didn't have a lot of waste with his ship if he wanted it gone, right? Just burned and it went away. The Titanic, we would have a lot of waste left over, even if we scrap metaled it. Okay? So, when we look at positives and negatives, one of your negatives
that we had to write down.
Any of those? Pick three.
Pick three of
Pick three.
water. Pick three like
Any of them. Doesn't matter.
There's non-vehicle ones too.
Pick three. Okay. Come back. Come on, there you go. Okay.
I can't see you, so
It's hard time in the dark. Okay. So if I have to scrap metal the Titanic, I've got a lot of waste, right?
right.
That's one of our negatives.
Got too much water.
That's a negative, is waste.
Where do we put that in there? Water.
What's the positive?
Positive is traveling long distance faster, and that's all you have to write. Traveling long distances faster. That's all you have to write. Traveling long distances faster. On negatives, there are two things I want. I want waste, and I want accidents. Waste and accidents, and that's all you have to write. Waste and accidents. Okay? Are we good? Can I move on?
Yeah. So that's like all of them?
Mm-hmm. That's all you have. We good?
Yep.
Okay. Energy and power. How many? Where are my graders? Okay. Okay. Shh. Look. Energy is going to be the ability or capacity to do work. The ability or capacity to do work. Is that potential or is that kinetic? That's potential energy. When we're talking, okay? We've got examples. You can pick three of these. Chemical energy would be gasoline. Heat, very good. Electrical energy would be electricity. Radiant energy would be light. If I lived in Alaska, where it is dark 3 months out of the year, would I want to put solar panels on my house? No.
That'd just be dumb.
That's right. It'd be very dumb. So a lot of times our technology evolves around the power sources that we have or the energy sources we have. Right? This drives our technologies. Are we good here? Everybody got three examples? Okay. And are we talking kinetic or potential? Very good. Potential. For this, we are talking potential. Okay. Can I move on?
Yes.
Okay. Power. Power, the definition for here, it's a little different than your science, is the rate at which energy is transformed from one form to another. So power is our rate. What we're talking about is making it go from potential to kinetic. Right? We have all kinds of different ones. We have electrical power that does our lights, our motors. We have mechanical that moves automobiles, trains, airplanes. We have fluid powers. We have hydraulics using a liquid. We have pneumatics, uses a gas. That P is silent. It's not pneumatics, it is pneumatics. And that's a gas. So positives. Some positives that we have. Without energy and power, most of our technologies wouldn't exist or work. That's all you have to write in the positive box. You guys are doing so well. I'm so proud of you. Did a good job. Okay. Is we're overusing our non-renewable resources. When we burn fossil fuels, what do we emit into the environment? Pollution. What is that called? Yeah. Greenhouse. If I am digging up concrete, okay, why? It's a lot faster, right? That energy and that power help my work, and it makes it quicker and easier. I can do the same thing. I'm going to hurt really bad afterwards. It's going to take me forever. It probably won't get done because I'll quit after the first couple hours, right? But jackhammer, I can get it done. Okay, you ready for the next one? My favorite, nanotechnology. Yes, ma'am.
You told me to talk about this. Okay, it's those little nanos.
Yep, hold on. Nanotechnology. This is manipulating materials on an atomic or molecular level. What is a molecule?
A molecule.
What is a molecule made of? Atoms. What is an atom? What's the best working definition for atoms?
It makes up everything.
It does make up everything. It is a building block, but it's also the smallest particle that will retain all the characteristics of an element. If I have one atom of hydrogen, it looks like hydrogen. If I have a proton off of hydrogen, it will not look like hydrogen because you need everything there together. When I say diameter, do you know what that means? Okay, diameter. So let's look at this circle. Diameter goes from this edge to this edge. So it's the width across the circle. Right? Okay, now I want you to pick out, don't pull it off your head. Mrs. Snook did not say pull your hair out. Okay? I want you to find one strand of your hair. Just one strand. Okay? One strand. Only one. Feel how small that is? The diameter of that is very tiny, isn't it? 10 nanometers is 1,000 times smaller than one. Okay? When we're talking nanotechnology, we are talking at the nanometer level. If it is 1,000 times smaller than this, are you going to be able to see it? No. See this guy? Okay? So, some examples are sensors, nanobots, and molecular manufacturing. That is stuff you guys can't see without a machine. You cannot see that with your naked eye. Naked eye means that it's just your eye without any aided devices, so you don't have a microscope or a magnifying glass.
I always think of it like if you don't have contacts or whatever.
If you have the contacts, it's still a naked eye because that's correcting to the point where most people would be at. Okay? Shh. We're almost done. You guys have done so well. What time is it?
3:20.
Awesome. We're going to get you out of here. Okay? So positives, and let's just look at the implanted sensors. Okay? And what they're talking about is sensors that they can implant here on you. There's sensors they can implant. They're looking at it with diabetics, with epileptics, so that they can treat you immediately, right? And so our positives are continually sense and adjust medical treatment. So if your blood, yes, that's your positive. You only have to write the one. So if your blood sugar drops, it knows to immediately tell the insulin pump to give you insulin. Then it can set and monitor you. There are some test trials with people with cancer that are taking a nanobot in, and it will tell if that cancer comes back.
Yeah, my papa and my older sister, they did that. My papa didn't come back, and my sister did do that.
That's good.
And she had breast cancer. And
But it's so small, we miss something, and then it comes back. And so those sensors can detect it and immediately send something, say, hey, whoa, we need to treat her. Right? Impeding privacy. Impede privacy. That's what you need to write for the... Impede means invading. Right? Touch. Are they going to hire you? If they know that? Why?
because you're really not gonna work.
You're going to miss a lot of proof. So I don't want their whole medical history out there for people to know.
Yeah, but they need it.
There is military technology right now. It looks like a mosquito, and it has cameras. It can infect computers with viruses, and it can also infect people.
That sounds so awesome.
Okay? It's a great spy technique. Right?
Yeah, but spies don't exist.
So, but you don't want it to land on you.
Yeah, but is it like a real mosquito?
No, it's mechanical. You could still switch it. Okay? We all good? Okay, now. Here's what we're going to do. Can I borrow yours? Okay. So, what I want you to do is you're going to take the front of your sheet that's got the box titles. You're going to take this one that has this plain back. You're going to put it behind it. When we get back in my room next week at some point, we will staple it. We're going to fold it. Okay? You're going to go to your engineering journal where you first drew the chart. And we are going to glue this in here. Right? Now, you want it so that you can open it and look at it for the test. Oh, yeah. Okay? We're going to staple it when we get back to my room, but right now we're just going to glue this white part. Okay? So go ahead and take care of that. Someone's got to have glue sticks, please. Is he? Okay. Your last thing to do. Answer these two discussion questions. What is technology? And what is the difference between technology and science? Okay? Woo, come back to me. Hold on.